2 papers down, 1 to go. Let's go ahead and look at the topics that came up in paper 2. So question 1, prime factorization and the lowest common multiple, then a Venn diagrams question, then a ratio and percentages question, then a table of values, which involved graphing a cubic graph or a cubic equation. Question 5 was on trig ratios, calculating the missing side of a triangle. 6 was a column vector question. 7 was finding the area of a quarter of a circle using Pythagoras. 8 was a percentage discount question, and then part B was a compound interest question. There was a box plot question, index laws, more index laws, a product rule question, finding the gradient of a straight line. There was a question on the sine rule. I think it was in a triangle, finding the missing angle in a triangle using the sine rule. 14, area of squares. So that involved algebraic problem solving. I think they told you, one square had one side longer than another square and you had to work that out. Transformations. 16, quadratic sequences. 17, you had to read the turning point from an equation in vertex form. 18 was on similar 3D shapes, specifically cones. That was a fairly interesting question actually. 19 was iterations, but it was presented differently to how you would usually see an iterations question. And actually I meant to erase this. I originally wrote it was outside the specification. I sort of take that back. It was a different question, but I don't think it was outside the specification. And that was, the hot air balloon question. 20 was probability, algebraic problem solving, one of those types of probability questions. 21 was graph transformations, and 22 was the equation of a circle. You were given 2 points of a tangent line, I believe, and you had to find the equation of the circle or something like that. Okay, so what has come up and what has not yet appeared? So we've had iterations, we've had compound interest, still no bearings questions, so possibly that might come up in paper 3. We've had graph transformations, no work rate problems. We haven't had a question involving angles in polygons. No circle theorems questions yet, no histograms questions, no upper and lower bounds or enlargement questions. We've seen similar 3D shapes and product rule as well. Now, it doesn't mean these topics will not come up in paper 3 again. It just means that there's a higher chance, or in my opinion, it means there's a higher chance of these other topics coming up. More possible topics, angle between a line and a plane, that might come up. Construction questions where you have to construct, the perpendicular of a bisector, or, construct the bisector of an angle, things like that, where you have to get your compass out. That might come up. And then there's been no simultaneous equations questions either. So now I'm going to go through some questions on these topics to help with your revision. So let's go ahead and get into those. As I said, there's been no circle theorems questions yet, so I'm going to go through a couple of circle theorems questions to start off. This question says A, B, C, D are points on a circle center O. OAC is a diameter of the circle. Angle AOD equals 98 degrees. Work out the size of angle DBC. Give a reason for each stage of your working. So angle DBC is up here. Sorry, not that one. DBC is in here. Okay, so the first thing I would say or recognize is that if AOC is the diameter, then this angle in here, ABC, must be 90 degrees. That's one of the circle theorems you need to know. That is the angle in a semicircle theorem. So the first thing I'm going to say here is angle ABC equals 90 degrees. And this is angles in a semicircle. And check out my video on all the circle theorems you need to know if you want to know more about that. Okay, so that's 90 degrees. The next angle we can find is ABD, this one in here, and that angle is related to this angle at the center. So if you look at this angle AOD, it's subtended by the same arc. So ABD, these lines AB and BD join at the same points. So we can say this angle up here must be half the angle at the center. Okay, so we can say angle ABD, ABD equals 98 divided by 2, which is 49 degrees, and that is the angle at the center theorem. And actually we might have to be more specific there. We might have to say angle at the center is twice the angle at the circumference. Okay, that is another circle theorem you need to know. So if this angle in here, ABD, is 49 degrees, this angle, this whole angle ABC is 90, this angle in here is going to be 90 subtract 49. So DBC, angle DBC equals 90 take 49, and that is 41 degrees. And we don't need to give a reason, that's just, arithmetic. So final answer there, 41 degrees for that first question. On to the next one. And did I give the marks for that? That was a 4-mark question, by the way. That was a 4-mark question. Okay, on to the next one. And I haven't written the marks for this one either. This is also a 4-mark question. Okay, this question says B, C, D, and F are points on a circle. ABC, AFD, BFE, and CDE are straight lines. Work out the sides of angle X. Show you're working clearly. Okay, so all of these points are on the circle. These are all straight lines, and this is the angle we're looking for. And by the way, I didn't mention this at the start, but give these questions a go if you're revising. Pause the video, give it a go yourself. So where to start with this question? Well, this question does actually boil down to solving simultaneous equations. So let's have a look at how you can create those simultaneous equations. The first thing you might notice is that this is a cyclic quadrilateral. That's a quadrilateral with all 4 points on a circle. And there's something you need to know about angles in a cyclic quadrilateral. It's that opposite angles add to 180. So you can say this angle in here is 180, take X. So its opposite angle, it must be, if they add to 180, this will be 180 take the other angle. And that means this angle in here, because these are two angles on a straight line, this angle must be X as well. Okay, and then over here in this triangle, these are two angles on a straight line. This angle is also going to be 180 take X. And then this angle in here, or these two angles, are vertically opposite. That must mean they are equal. So I'm going to label that Y, and this one will also be Y. So now we have two triangles, and we know the angles in a triangle add up to 180. We're actually going to create two equations, and that's where we're going to get our simultaneous equations. So for the first triangle, let's add up these angles. We'll have 54 plus Y plus 180 take X. That must equal 180. This is angles in a triangle. And actually, we probably should outline how we got these other angles. So let's just add a bit of working out here. The other equation, looking at the other triangle, was I could say these angles also need to add up to 180. So I can say X plus Y plus 32 equals 180. And now I want to go ahead and try to simplify these equations. So if I call this equation 1 and this equation 2, I might just go down here so I have a bit more room. If I simplify this, the first thing I could do is subtract 180 from both sides. That would cancel out that 180, so that effectively disappears. And then I could subtract Y and X, or add X and subtract Y. And then on the right hand side, I would have X take Y equal to 54. So hopefully you can see how that's simplified to X take Y equals 54. Then equation 2, simplifying this, I would subtract 32 from the right hand side. 180 take 32 is 148. So I'd have X plus Y equals 148 degrees. And now think about how you could solve for X with these equations. What do you do when you have simultaneous equations? Well, you can either use substitution or elimination. Here, to eliminate y, I can add these equations because I have a negative y and a positive y. If I add these equations, that will cancel the y out. So x plus x is 2x. Negative y plus positive y is 0, so they disappear. And then I've got 54 plus 148. That is 202. And then dividing both sides by 2, I have x equal to 101 degrees. And that is your final answer there. So that was a fairly tricky 4-mark circle theorems question, especially compared to the last one. Okay, on to the next one. This question says A, B, C, and D are points on a circle. TDV is the tangent to the circle at D. AB equals AD. Angle ADT equals 71 degrees. Work out the size of angle BCD. Give a reason for each stage of your working. And this is a 5-mark question. Where to start here? Well, whenever you have this situation where you have a tangent and an angle between a line and the tangent, that usually indicates you can use the alternate segment theorem. Now, to use the alternate segment theorem, we need to draw this triangle in here. Okay, because the alternate segment theorem says this angle is equal to this angle up here in the alternate segment. That is another circle theorem you need to know. So be familiar with that arrangement. And now we know this angle will be 71 degrees. So let's go ahead and write that down. We know angle ABD equals 71 degrees. That's the alternate segment theorem. And now this line we drew also created an isosceles triangle. So this angle is the other base angle of this isosceles triangle. That means this angle also must be 71 degrees because base angles in an isosceles triangle are equal. So we can also say angle BDA equals 71 degrees because it's an isosceles triangle. Next, remember we're trying to work out the size of angle BCD, that's here. If I work out this angle, again we'll have that situation of opposite angles in a cyclic quadrilateral. If I can work out this angle, I can work out this angle over here. So angles in a triangle need to add up to 180. So I can find this angle, which is angle DAB, dab on that angle. That's going to be 180 take 2 times 71. So that's 180 take 142, which is 38 degrees. Okay, so this is 38 degrees over here. And then opposite angles need to add to 180. So I can then say angle BCD equals 180 take 38. Which is 142 degrees. And that is because opposite angles in a cyclic quadrilateral. And that is your final answer there. Okay, so 3 circle theorems questions. Let's move on to an upper lower bounds question. This question says C equals B take A equals 6 correct to the nearest integer, B equals 15 correct to the nearest 5. Work out the upper bound for the value of C, show you're working clearly. The first thing you want to do is find the upper and lower bounds for both A and B. So if we say A equals 6, let's draw a little diagram. Now if it's correct to the nearest integer, write the integers closest to 6. So 7 is 1 greater than 6 and 5 is 1 lower than 6. Then draw some lines here. We want halfway between these because anything, halfway greater than halfway is going to round to 6. Anything less than halfway between 6 and 7 is going to round down to 6. So they are your bounds there. So in this case, we've got 5.5 is halfway between 5 and 6, and 6.5 is halfway between 6 and 7. And then we need to write A is less than 6.5. It's not going to equal 6.5 because 6.5 itself would round up to 7. It's just less than 6.5. And it's greater than and equal to 5.5 because 5.5 would round up to 6. Then for 15, correct to the nearest 5. Again, draw a little diagram. Write the number 5 greater than 15, so that's 20, and 5 less than 15, that's 10. and then you want halfway between these gaps. So halfway between 10 and 15 is 12.5. Halfway between 15 and 20 is 17.5. And again, write this as well. So b is less than 17.5 and greater than or equal to 12.5. So they're your upper and lower bounds for a and b. Then you need to think about this equation here. So we want the upper bound of c. How could we get the largest possible value of c? Well, we would want b. We would want the upper bound of b, the largest possible value of b. We want its upper bound. And we want the smallest possible value of a. So we want the lower bound for a, because that's going to give you the largest possible value for c. If you took the lowest value of b and the largest value of a, you're going to get a smaller value. So take the upper value of b, upper bound, that's 17.5, subtract the lower bound of a, 5.5, and that gives you your final answer of 12 for the upper bound for c. Okay, let's continue on then. Here is a fairly tricky bearings question, and no diagram with this one, so you're going to have to draw the diagram yourself. Question 23 says a boat sails from point X to point Y and then to point Z. Y is on a bearing of 280 degrees from X. Z is on a bearing of 220 degrees from Y. The distance from X to Y is 3.5 kilometers. The distance from Y to Z is 6 kilometers. Work out the bearing of Z from X. Give your answer correct to 1 decimal place. Okay, so firstly, draw in point X. Okay, this is X, and that's Y is on a bearing of 280 degrees from X. So if I draw my north line, if I go around 280 degrees, that's going to be more than 3/4. So it's going to be like up like that somehow. Okay, and then it doesn't have to be exact, of course, but just get this diagram. It helps with your working out. So then we have another north line here at Y, and Z is on a bearing of 220 degrees from Y. So if we went around 220 degrees, that's, a bit more than 180, so it's going to be down here somewhere. Again, just doesn't have to be exact, just a rough diagram. And Z would be down here. Now this distance from X to Y is 3.5 kilometers, and from Y to Z is 6 kilometers. 6 kilometers, and we want the bearing of Z from X. So next, draw a line in from X to Z, and we want this angle around here. Okay, so how can we get there? Well, firstly, fill in the angles that we know. If this is 180 degrees around to this line, to Y, that means we can work out this angle in here. So that would be 360 take 280. That is 80 degrees in there. Also, we can work out this angle. These angles need to add to 180. Interior angles in parallel lines, that would be 100 degrees. And remember, this angle all the way around is 220. So this angle in here must be 120 degrees. As soon as you see this arrangement in a bearings question, usually it indicates you want to use the cosine rule. We cannot actually figure out any other angles in this triangle. We can't find this angle or this angle with just using the angles. So we're going to have to use the cosine rule to find the length of this line, and then we can go ahead and find this angle in here. Once we know that angle, we can work out this angle as the bearing of Z from X. So firstly, the cosine rule says a squared equals b squared plus c squared. Take 2bc cosine A. A in this case is going to be this line. B and C are the adjacent sides to this angle, and the angle A is this 120 degrees. So let's go ahead and plug those in. B can be 6 squared, C can be 3.5 squared, and then we subtract 2 times 6 times 3.5 multiplied by the cosine of the angle between those sides, so cosine of 120. Okay, then we get our calculator out and we plug that in. So 6 squared plus 3.5 squared, take 2 times 6 times 3.5 multiplied by the cosine of 120. And that gives me 69.25. Remember, that's a squared. So we want to take the square root of that angle, that answer. And I get 8.32 and so on. So 8.321. And go ahead and write down all of those decimal places just in case. So 321658489. So we know the length of this side, 8.32 approximately. Then we can use the sine rule to find this angle. So the sine rule says the sine of this angle, sine of theta, divided by its opposite side, 6, equals the sine of 120 divided by its opposite side, which is the answer we just found. Okay, so then we can find theta. So sine of theta will equal 6 times this, sine of 120 over 8.32, and then theta will be the inverse sine of all of this. Then let's go ahead and plug that into a calculator. So we have the inverse sine of 6 times the sine of 120 divided by our previous answer. Now use the answer key on your calculator. It's going to save you entering that whole thing again. And enter. And I get 38.639 and so on. So 38.639. That's this angle in here. We haven't finished yet. Remember, we need this entire angle around the outside, that reflex angle. So to work that out, we want to add this to 80 degrees. So the bearing is going to equal 360. The angles around a point, subtract 80 plus this answer here, this angle in here. So 38.639. And if we put that into a calculator, 360 subtract 80. Sorry, that should be a subtract as well. I don't know why I put plus there. So we're subtracting both of those angles. I guess I meant like we could put a plus and then brackets around that. That would be accurate. But we can just subtract it as well. Okay, so we also want to subtract that. So subtract our previous answer. And I get 241.36. So 241.36. And the question says, give your answer correct to one decimal place. So we want to round that off to 241.4 degrees. And that is your final answer for that bearings question. Fairly difficult 5-mark question there. Couple more questions. We've got some histogram questions here. So this is a fairly typical draw a histogram question. It says the table gives information about the heights of some trees. So here's the table and the frequencies. On the grid, draw a histogram of this for this information. So here's the table. We have the heights on the horizontal axis and the frequency density on the vertical axis. And to draw a histogram, you want to work out the frequency densities. Frequency density. To work this out, you do the frequency divided by the class width. That's what gives you the frequency density. So use your calculator for this. 15 divided by 20. So 15 divided by 20, 0.75. Next one will be 48 divided by 15. So the difference between 20 and 35 is 15. So 48 divided by 15, put that in, you get 3.2. 21 divided by 5, 4.2. And 16 divided by 10 is 1.6. So they're your frequency densities. They're your heights of your bars on your histogram. Okay, so might have to zoom out a little bit here. So the first bar is going to have a width of 20. So it's going to go up to 20 and it has a frequency density of 0.75. So look carefully at this scale. This one is going up by 0.1 or tenths. So 0.75 will be between these two lines here. Okay, so we're going to draw in. Okay, I can't get it exactly. All right, there we go. That's pretty good. So that's the height of my first bar up to 20. My next bar is going to have a height of 3.2. So 3.2 is up here, and that's between 20 and 35. So a lot of things you have to get right here. You have to get the heights right and the widths correct. So that would be your second bar. The next bar has a height of 4.2, and that's from 35 to 40. So 4.2 is here, and only a width of 5. Remember, histograms usually have different widths for the bars. That's the usefulness of a histogram. And then the last one is 40 to 50 with a height of 1.6. So that is here. 1.6. Almost going cross-eyed looking at these little lines. All right. So there's your histogram. That's how a fairly typical approach to drawing a histogram. Work out the frequency densities, then draw your bars. Okay, and that was a 3-mark question, by the way. Another question on histograms. This is the other type of question you usually get about histograms. This one says, histogram shows information about the ages of all the passengers traveling on a plane. No one on the plane is older than 80 years old. 24 passengers on the plane aged between 40 and 60 years. Work out the total number of passengers on the plane. So the bar relating to 40 to 60 is this one. If they tell you the number of passengers in this bar is 24, you notice there's no scale on the vertical axis. That allows you to calculate the scale. So to work out the frequency density, remember we do the frequency divided by the class width. So 24 divided by 20, that's going to give you a frequency density of 1.2. So the height of this bar is 1.2. That tells you the scale here. So if that's 1.2, this will be 1, and we're going up by 0.2 for each little line. That allows you to calculate the frequency of each of the other bars. So that's what we need to do next. This will be 0.4. 0.4 times the class width. 0.4 times 10 is 4. This has a height of 1.8. 1.8 times 10 is 18. This third bar has a height of 1, 2, 3, 4, 5, 6, 6.4. And that's multiplied by 5. 6.4 multiplied by 5, I worked this out earlier, that's 32. The next bar has a height of 2. 2 times 15 is 30. And the next one has a height of 0.8. 0.8 times 20 is 16. Okay, then when you have all of the frequencies, add those all up. 4 plus 18 plus 32 plus 30 plus 24 plus 16 gives you a total of 124. So that's the number of passengers on the plane. Part B says a passenger on the plane is picked at random. Work out an estimate for the probability that this person is older than 55 years. Okay, so again, looking at the diagram, 55 is here. So I'm going to rub out that 24 now. A couple ways you can approach this. I would probably just think about what fraction of the bar is above 55. So if this is 20, an interval of 20, you have 15 below 25 and 5 above it. That means this is 3/4 of the interval. This is 1/4 of the interval. So to work out the number of people in this interval, remember there was a total of 24, we'd take 1/4 of 24 above 55. So we want to do 0.25 times 24. That will give you the number of passengers in this section. And then we also want to add on 16, because remember the question says work out an estimate for the probability that this person is older than 55 years. That also includes this bar here. So we're going to do 0.25 times 24 plus 16. And that is 6 plus 16, that's 22. So now we want the probability. The probability is that number out of the total. So 22 out of 124, the total number of passengers. And it doesn't say to simplify, so you can leave your answer as that. Okay, so that are 2 histogram questions. Something else that might come up, construction. So here's a fairly typical question. Use a ruler and compass to construct the perpendicular bisector of the line DE. You must show all your construction lines. So I didn't include the line, but they would give you a straight line in the question. So a bit of a reminder here, I don't have a compass on my screen here, but I can still demonstrate how you would do this. So draw two dots, sorry. Doesn't really matter where they are. Actually, it's probably easier if they're not too far apart. So something like that. Get your compass, set it to a certain length, and that length needs to be just a bit more than halfway between those 2 points. So wherever you draw the points, make the width of the compass just over halfway, and then draw a semicircle around one of the points. So the center of the compass on the point, draw a line with your pencil like that. Now be careful, keep the width of the compass the same and put the center on the other dot and draw a circle around that dot. And then your perpendicular bisector is the straight line between where they intersect. So take your ruler, line it up with these intersection points and draw a straight line through those, and you're done. So that's a quick reminder of how to construct a perpendicular bisector. Next, we have the angle between a line and a plane type of question. So this is the second last question I'm going through. This question says the diagram shows the cuboid A, B, C, D, E, F, G, H, and I've just wondered, did I put marks on this one? This was a 2-mark question, by the way. Okay, sorry about that. Okay, so we have a cuboid. For this cuboid, the length of AB to the length of BC to the length of CF equals 4 to 2 to 3. So AB is 4, BC is 2, CF is 3 parts of the ratio. Calculate the size of the angle between AF and the plane ABCD. Give your answer correct to 1 decimal place. When you're looking for the angle between a straight line and a plane, firstly draw the line in. So we're looking for the angle between AF, which is here, and the plane ABCD. Once you've got that straight line in, draw a straight line below it to the same corner. The way I think about this is, it's like if you're looking from above, it would be directly below that line. So it's like this shadow if you shine a light straight down on that line. So you've created another triangle there, and what we're looking for is this angle between AF and AC. To work out that angle, we want to find the length of AC, or the relative length. Now, because we're only looking for an angle, we don't actually need to know the lengths of these sides. We only know the ratio of the lengths, and that's all that we need, because again, we're looking just for an angle. So we don't have to work out the lengths. We can just use these numbers, and we can say AC equals, well, using Pythagoras' theorem, AC is going to be the square root of 2 squared plus 4 squared. And if you want to be completely mathematically correct, you could write an x there, like this is 4x, this is 2x, but you don't really need to get the correct answer here. So AC would equal the square root of 2 squared plus 4 squared, that's 4 plus 16, that's 20. So AC is the square root of 20, and then we've got this length, and this length, we can work out the angle using the tangent ratio. Remember, the tangent of an angle is equal to the opposite side, 3 over the adjacent side, square root 20. And then theta is going to be the inverse tan of 3 on square root 20. Okay, so then put that into your calculator. The inverse tangent of 3 on square root 20, and I get 33.85 and so on, 33.85, which rounds off to 1 decimal place to 33.9 degrees, and that's your final answer for that question, and that was a 3-mark question. And the final question here, I thought this was a bit of a different one. It says, find the smallest whole number that 720 can be multiplied by to give a square number. And this is just for 1 mark. So what you can do with this type of question is just use trial and error if you like. You can just multiply 720 by 1. That's going to be 720. And, well, if you want, you can, this is a calculator paper, so take the square root of 720. And you notice it's not a square number. You'd have to get a whole number answer to that for it to be a square number. And you can keep doing that. 720 times 2. 720 times 3 until you get a square number there. But there's a way to work this out without trial and error, and I thought that was a bit interesting, so I thought I'd go through that. So what you need to do if you want to solve this without trial and error is to find the prime factors of 720. So use prime factorization. 720 is 9 times 80. Remember, 9 times 8 is 72, so 9 times 80 is 720. And then this is 9 times 8 times 10. And then we can write this as 3 squared times 2 cubed times 2 times 5. And simplifying this is 2 to the power 4 times 3 squared times 5. Now, to have a square number, all of the exponents of the prime factors need to be even. So you notice the exponent of 2 is even, the exponent of 3 is even, the exponent of 5 is 1. So what we'd want to do is multiply this whole thing by 5, and then we would get a square number. And that is actually the answer here. The answer is 5. And that's one way you could work it out without trial and error. But if you're not comfortable with this, trial and error is absolutely fine for this type of question. I just found it interesting, you know, how to work this out without trial and error if you were interested in that. So, you know, that tells you the answer must be 5. So 720 times 5, if you put that into a calculator, is 3,600, which is 60 squared. So the answer to multiply 720, the whole number to multiply 720 by is 5. Okay, so they are some questions hopefully are useful to you in preparation for paper 3. Thanks for watching. I'll see you in the next one. Bye for now.